Well, we appreciate everyone in the room here. So we'll get started, and we want to make sure that we're catering to you and what you came here for. So before we start this great panel, my name is Hasmeen Tresky, and I am here to represent the MKE Tech Hub Coalition. For those of you who are new to the space, haven't attended any events this week, we are hosting MKE Tech Week, and we have 40 plus events that you can attend, whether you're an entrepreneur, an innovator, or in education. There is something for everyone. So we are glad to see you guys here today. And just to plug in a couple of events to follow, we do have the Startup Showcase starting at 6 p.m. over at Hush Blackwell. Tons of Milwaukee startups are coming out to showcase their businesses, and I encourage you to come out and learn and just get to know some of the entrepreneurs in the city. And the other plug is, if you haven't received a book already, we are providing free The Rise of the Rest books at the front as soon as you walked in from Steve Case. Tomorrow he's coming into town. And so we have quite a few events tomorrow wrapped around Steve Case. If you don't know who that is, he's the founder of AOL and of Revelation LLC, a venture capital company. So we have our 3-year anniversary we're celebrating tomorrow afternoon. Be sure to check out mktech.org if you guys are interested in being a part of that conversation and just learning all about the work that everyone's doing here in the coalition. With that, I will get out of the way because we're already on the start to this panel, and I'll give you guys Mark Zakar from NM.
Thanks, Yasmin. So again, my name is Mark Zakar from the Northwestern Mutual Data Science Institute. I'm the Talent and Community Program Manager. It's my pleasure to be the moderator for this panel discussion today on democratizing AI education. So we'll get into some of the best practices and the barriers to this work in southeastern Wisconsin, and some of the innovative work of our partners at MSOE, UW-Milwaukee, the Milwaukee Tech Hub, and Rex Academy. So before I introduce the panel, I wanted to share this vignette of why I was reminded of the importance of this work just last Friday. A senior data scientist at Northwestern Mutual shared with our data organization that Andrew Ning, co-founder and head of Google Brain and co-founder of Coursera, where he teaches a phenomenal machine learning course, by the way, that is open to all. So if you haven't taken Andrew's course on Coursera, I highly recommend it. He has a blog called Deep Learning AI, and so he posted just on Friday this. He said, "I'd like to address a serious matter of newcomers to AI, sometimes experiencing imposter syndrome, where someone, regardless of their success in the field, wonders if they're a fraud and they really belong in the AI community. I want to make sure that doesn't discourage you or anyone else from joining us. Let me be clear, if you want to be part of the AI community, then we welcome you with open arms. We want you to join us, and you fully belong from the very beginning. AI is technically complex, and it has its fair share of smart and highly capable people. But it's very easy for us to forget to become good at anything, the first step is to suck at it. So if you've succeeded already at coding or sucking at AI, then you are on your way, and we welcome you to join us. So that's where I am. And so I know our panelists all very well, and rather than read long bios, what I'm going to do to introduce them to you is by ask them a big question about the why of their program, and then they will be able to introduce themselves and answer that why as part of their introduction. So Ben, we're going to start with you. The UW-Milwaukee College for Kids and Teens program has been around since 1980. That's over 40 years of programs. That is incredible. Why has the Northwestern Mutual Data Science Certificate track been added to that program, and how has the addition capitalized on your historical success?
Well, thanks for that, Mark. Like you said, my name is Ben Leduc. I am the program director of UWM's College for Kids and Teens program. As you said, this will be our 43rd year in existence on the college campus at UWM, offering programs for kids as young as K-5 all the way through 12th grade. The question Mark asked was, why did we decide to partner with NM to offer a data science certificate? It's kind of a multi-layered answer to the question. First and foremost, when I took over as director of the program, one of my main focuses was to increase the ability and access to students, to give them more opportunities to learn about a myriad of different things. Including AI, data science, and things like that. About 3 or 4 years ago, we were introduced to the fact that the Data Science Institute was going to be coming into an existence, and they were reaching out to find partners to offer pre-college programming and data science to younger students, to introduce the field and also to introduce more STEM opportunities for students. College for Kids and Teens saw that as a great opportunity, and I saw that as a great opportunity to learn something new myself. I'll be honest, I didn't know what data science was before then, but also to give the youth in the greater Milwaukee area an opportunity to get their footing, to learn about this new up-and-coming field that is essential to every type of industry that you can think of and any kind of interest that you have. So our focus then was to partner with NM to create a data science certificate to give these students an opportunity to get their foot in the door, to learn about data science, to learn about AI, and to understand the field so that when they get to college, they have a good foundation for what they're ready for. On top of that, we decided that we wanted to expand our programming, and the certificate program was a way to give these students a chance to take some classes over the summer where there isn't assessments, there isn't grades, it's just learning for the sake of learning and having fun. But at the other side of that is at the end of it, they walk away with something that they can put on their college resume as they're looking to start at colleges. And it also gives them experiences and understandings as they get into the field and when they get into UWM and the new data science program that started at UWM, giving them that first step in understanding what it would be to be a data scientist.
Gabe, coming to you next. So if you don't know, the Milwaukee Tech Hub has its own set of programs, and Fuse is a pre-internship program that's one of those exclusive to the Tech Hub programs. And they've partnered with MSOE. This is their second summer offering the HERA, Higher Educational Regional Alliance, AI and Ethics badge to students. And so, Gabe, why did you from MSOE get involved with the Fuse pre-internship program, and what were the students able to accomplish this summer?
Sure. So I'm Gabe. I'm a second-year computer science professor at MSOE. And I'll answer the second part of that question first. I'll give you a little bit of a background on what Fuse is. Fuse is a program that is run by the Milwaukee Tech Hub that gives upper-level high school students, and then we're primarily targeted at college students. I think we were like 80% college students, about 20% high school students. It gives them a funded, so it's free. It's they don't have to pay tuition for this. It's a way to get students who are maybe not necessarily in a tech-focused major, a way to get in the door, to try and get their foot in the door to maybe a tech-focused career eventually, or at least get them thinking about what a tech-focused career could look like. And so it's an 8-week program. The first 5 weeks have a couple of different components. With it, we do some professional development that we partnered with the Commons for, that they do, they help them build a LinkedIn, and they help do, like interview prep and resume prep and all that sort of stuff. Then there is what we called the tech skill modules that Sandy and Rex Academy run. I'll let her talk about those. Then there was some extra content that me and some other volunteers helped create. And that included like panel discussions with people who work in industry to talk about like what their daily life looks like, how they got to the positions that they're in. And then there was also some sort of more standard like lecture content that it was like I gave a lecture on like where machine learning can fail and why it can fail, which sort of ties into this topic of data literacy that we're going to be talking about a little bit throughout this panel. And then Liz Taylor from MSOE, who unfortunately couldn't be here today, gave a talk on the 5 big ideas of AI. And then after those modules were sort of interwoven in the first 5 weeks, we then created teams for our students and gave them a broad, open-ended question from an industry partner and gave them basically 3 works to try and come up with a solution, propose a solution to this problem. And then the program culminated with a demo day where we were at Pfizer Forum back in person, because most of this was delivered asynchronously and done online. where students could present sort of what they came up with for those 3 weeks and meet partners in industry and sort of do some of that networking that can be really important for helping eventually lead to a job or a career in a tech community. And so that's the high level overview of what the program was. I was in my first year at MSOE last year, and one of my senior faculty who I had been working with a lot knew Laura from the Tech Hub Coalition and knew that they were looking for a new curriculum advisor. And he knew that sort of part of my passion, one thing I really enjoy about being a computer science professor is I really enjoy teaching those sort of foundational classes where you help students sort of build those foundational skills, those like intro programming skills, intro data science, AI skills. And so he recommended to me that I reach out to Laura and Hasmin to talk more about this sort of position that we knew they had open. And then so I had a meeting with them. And I felt like I could help contribute to helping these students create those sort of foundational skills. Even though it was an 8-week program, I can only do so much, but I felt like I could contribute to helping them sort of take that first step to if they want to pursue a career in tech. And I think overall through the summer we were able to do that.
Great, thanks, Gabe. And Sandhya, you're next. So Rex Academy partnered with the Fuse program this past summer for the purpose of upskilling these students in the fundamental skills of data and analytics. So Sandhya, what are those particular skills that Rex Academy contributed towards educating the students on, and why are those skills important to those students?
Yep. Thanks for asking that question. I'm Sandhya Padala. I go by Sandy. I'm founder and CEO of Rex Academy. At Rex Academy, we provide computer science curriculum and remote CS teachers for K-12. So as Gabe has mentioned, we have partnered with with MKE Tech Hub to cover the skills portion of 3 weeks for the Fuse program. And a few other folks on my team were more close to the program, but they're not Milwaukee based. So I'm here, and Indira Vadapalli on our team, she's our data analytics and AI expert. So she has told me a few things that students have learned in the data analytics part of the program. So they have learned how to read the data, analyze the data, and make sure they're collecting the right data, which is inclusive, does not have any bias in the data, and then present the data in a way that it's easily understandable. And data is very powerful. Like unless you make it, it's a lot of information, but unless they make it as a knowledge, it's not of much use these days, especially with so much amount of data information available at the tips. So, and as Gabe has mentioned, like at the end of the program, the students has come up with AI projects that spanned several industries, healthcare, insurance, to name a few.
All right, and you'll probably notice Michelle is not Liz. Liz, our representative from MSOE STEM Center, unfortunately got sick this afternoon, and so Michelle is pinch hitting for Liz. But what Michelle is bringing to the table into the conversation today is as a Northwestern Mutual industry leader in technology and data, why does Northwestern Mutual believe that it is vital that their workforce is data literate? And what data literacy efforts have you implemented for the company?
Green means on. I am the ultimate pinch hitter, everyone. Okay, so now my joke is not going to land. I've never been called Liz. I've been called Heather. I've been called Melissa. I've never been called Liz. But so I'm Michelle Featherston. I am a lead program manager at Northwestern Mutual. And among other things, my role involves data literacy, programming, and education for the company. Why we believe it's important: data is everywhere. Data is vital to NM's future. We need to be able to use and, even more importantly, communicate with it effectively in context. So we've been piloting a number of different things over the past year plus that I've been doing this work, including an independent learning path. We have a community of data enthusiasts that's voluntary for people to join. We have an emerging data leader program where we're trying to use I call them durable skills or power skills rather than soft skills, but train some of our data practitioners in things like communication, collaboration, problem solving, really focusing on those and then applying what they learn to help them grow data literacy at NM, but also grow their careers. So that's a bit about what we're doing. I come at this work from a bit of a different background. I am a high school statistics dropout, so the access and belonging piece is very important to me. But I also come at this from studying communication and learning and development and kind of developed a passion for data on the side. So I really look at everything through that communication foundational lens. If we can't get the message across clearly about the impact of the data, then it's not going to do us any good.
All right, and just a reminder, if anyone is online, this is a hybrid session that's being recorded. If you are online, you can feel free to ask questions in the chat, and we will ask them to the panel in a few minutes. So, but now I'd like to get into the weeds of the work a little bit. I don't have a deck. We're not going to get into any policies or standards, but I want to get into the nitty-gritty of what these 4 practitioners have been doing with their programs. So I think Gabe and Michelle, we'll start with you and talk about are the students today, the students that you're seeing, the students of industry, the students at MSOE, are they more data literate and experienced with data or experienced with artificial intelligence than you were as a student? And if you have an example, great. Or how is that the data literacy of the culture manifesting itself in your students?
I can start. So even just since I was an undergrad roughly 10-ish years ago, by and large, the students that I see are more, I would say, tech literate as a whole, and that lends itself to being more AI literate. There are, back when I was an undergrad, again, this wasn't horribly long ago, I went to a smaller liberal arts school that didn't even have a computer science major at the time. They've obviously sort of since learned that that's probably an important thing to have in this day and age. And, that sort of philosophy that, hey, computer science, and then because of, sort of that encompasses data science, AI, machine learning, is a very important skill, right? Liberal arts schools are starting to realize that. High schools are starting to realize that. There's certainly just, I think, more opportunity and more understanding of these programs being really important, both for helping their students lead to careers, but also just in general, that's sort of the way the world is going. And because of that, sort of, there's this computer science has become sort of this really important pillar of a piece of education that students get exposure to a lot earlier now. And with that, that leads to them coming to college. So when I first see them as freshmen, by and large, they have, a number of my students have already been programming for years by the time they get to me. And then that helps them utilize sort of all the resources that are at their disposal to, we don't really do anything data science, machine learning, AI until their second, third, fourth years at MSOE. But some of the students who get there with skills join, the AI club early on and start working towards building really cool AI projects as early as their freshman year. One really cool opportunity that we have at MSOE where I see this is that we have a supercomputer. We're blessed enough to have an alumni who is a higher up at NVIDIA who built us a supercomputer. And they sponsor a what we call the Rosie Awards. Our supercomputer is called Rosie. And that allows students to put in personal projects to sort of do anything in the realm of, again, data science, machine learning, AI, anything that uses the supercomputer to train their models. And a number of my students who just had the interest and built their own personal passion projects presented, and I was just remarkably impressed. The one that really stands out to me is one of my students. He created essentially a deep fake animator that takes a animated picture and builds a model so that you put in a video of your face recording, and it will translate your facial expressions onto this animated picture, a still animated image. And he gave a demo during the Rosie Awards, and it just was remarkably impressive to me. He was almost to creating sort of a real-time animator. He was up to, I think, 28 frames per second, and he was trying to get to 30, so he was almost there. But yeah, that's just one example of the sort of passion projects that students can build. And they take these skills that they've had some exposure to early on, and they can do really, really cool things with them.
So I am actually going to say yes and no. And I went to undergrad. I won't say when, but it was definitely more than 10 years ago. And so I say yes and no because, yes, there's a lot more tech tools out there, and students certainly pick them up and they learn them quickly. And we see that with employees too. They figure things out. But one of the challenges we've seen in the workplace with data literacy is especially taking the data literacy programming to data people. A lot of them are kind of like, well, duh, I'm already data literate. I'm working with data all day long. And then I sit through these presentations where they go over time and I couldn't pick the main idea out of what they're trying to, and what's the key business takeaway. And I go, oh gosh. And some of that is me learning as I go, programming, how do we reach people effectively? But so that's one piece of it, is people understanding, like realizing what's for them and valuable to them. I studied in my PhD program the communication surrounding work and careers. And so specifically, like what motivates students to seek career information online. And one of the things I found in that research is we assume that these students are digital natives and tech savvy and they just know what to do. They don't. They still need guidance. Yes, they pick up TikTok on their own and that kind of thing. But if it's not something that they have picked up on their own, they really need to be told, how do I use this? How is it valuable to me? And I think we take that for granted in this day and age because of all these tech advancements. And so I think that part is really important to not lose sight of. I also think, they're like, it's cool, all the things that people have been exposed to early on and these opportunities that people have. But I also wonder about the people who feel like it's not for them. Did they struggle in math? And so they feel like they can't do data or they can't do computer science because the math course was not for them. And do they sort of opt themselves out when really like they could bring a lot to the table? And so I think a lot of it has to do with those messages and making sure that people really feel like this is an option that anybody could potentially pursue. And there are a lot of organizations doing great work. There's things like Girls Who Code and the like to encourage people. But we can't just do lip service to those programs. We really have to make people feel like, help them, encourage them to try and see where they fit, because it may take time to find the right thing. As I said, statistics drop out, and then I went and did quantitative PhD research. So, if I can do it, anyone can, I promise you.
So, Ben, with these digital native students, have you had to overcome barriers in growing your data science track? Are those barriers systemic, local, something else? What needs to be true to grow your AI education program at UW-Milwaukee?
Well, obviously, the biggest problem we've had most recently has been the pandemic. That was a little bit difficult, but that's right when our program started. It was right when the pandemic struck. But in that first year, because of the fact that it opened up this new door to people being more comfortable with doing online coursework, it meant that we actually had 17 people in our first introduction class to data science for our track, our certificate track. And what it did was it opened the door for kids to feel comfortable in this field. But as far as addressing the question that Mark just asked about, what were some of the things, the barriers that prevented us? Being part of a university is a wonderful thing. I'm proud to be a part of UWM. I'm proud our program is part of UWM. But the obvious answer to that question is funding. We're a part of the university, but we're still dependent upon making money as a program to sustain ourselves. We don't get a lot of funding from the state to run our program. So finding partners like NM to not only help us with the curriculum and bringing in the proper people to teach the courses and to help teach the courses, they've also been willing to help us with funding aspects of the program. So that's one of the barriers that definitely comes in, because when you offer a program like this, you want to make sure you have the right instructors, you want to make sure you have the right materials, supplies, and equipment to do your data. And even though we're part of a university, you'd think, yeah, of course they have all that stuff. Well, we don't always have access to it because we're just the youth program on campus. We're not part of the computer science department. We're not part of, so sometimes it's about making the right inroads, making the right partnerships, and meeting the right people and connecting to the right people. Another big one has been getting the audience. I think that, like I said, the first year we did really well. We did well again, but finding the right audience. I would say overall, the majority of the students over the first 3 years that we've offered this data science certificate, a majority of them have been male, and we'd love to see a little bit more diversity in that group. We've had a couple of wonderful students that have completed the program in the first couple of years, but we'd like to see more diversity. Our first year offering the class, one of our teachers was a local high school high school teacher that taught data science at her high school. So there's that little bit of an inroad, but majority of the schools in the greater Milwaukee area, they don't teach anything that has to do with data specifically. We're starting to see that, and that's where partnerships and programs like ours and all the other programs are up here. We're starting to give that knowledge to the students, so there's a more base level of people that would be interested in taking these types of courses. But to the average student, if you say, would you be interested in a data science certificate, they ask you, what is that? So getting the word out there. And I think for a program like ours, where we start students as young as 5 years old, we start working and offering classes that may not be directly data science, obviously, for a 5-year-old, but they're getting into coding, they're getting into Lego robotics, they're getting into courses that start to build a foundation to get their interest into those types of things. And as far as whether the barriers are systemic, local, or I would say the answer is all of the above. I mean, when you work in youth programming, you're really, it's an uphill battle. You're trying to give these students and give these youth an opportunity to learn new things, but finding ways to do that sometimes is difficult, and finding the right partnerships and the right people to build with you to give those kids the access so they can come in and take it is part of the problem. And I would say the final thing for us is finding the right people to teach the classes. We've had the great opportunity to bring in some wonderful people. We've had some NM volunteers that have helped with courses, but we've had a couple wonderful teachers the last 2 years. A local data scientist that actually retired and then started his own business. His name is Pat Williams. He volunteers this time to teach the class, the introduction to data science class, and that's been amazing. And one of the other great parts of our program is that our entrepreneurial data science course, which is one of the 3 core courses, that really gives the students something that is more tangible to them. It's something that's more, in their wheelhouse. They can take something that they're interested in and teach that class. And this last year, we brought on a wonderful new teacher. His name is Quentin Prince to teach that course. So finding the right people and finding the right opportunity.
Great, thank you. So I have 2 more questions, and then we'll start to open the questions to the audience. So Sandhya and Gabe, when you think about AI, there's this old blog that's really well quoted, and you can find it. It's called the AI hierarchy of needs, that AI is this upper echelon of work. In order to do AI, you need machine learning. In order to do machine learning, you need data science. And in order to do data science, you need great data engineering. So are those disciplines, are they distinct in your curriculum design at Rex and an MSOE, or are you entering the curriculum in the middle there somewhere? Are you starting with data literacy and data engineering and working your way up to AI? Or how do you get to AI without these other hierarchy of needs that students need in skill-wise?
So at MSOE, actually, if you look at our curriculum and sort of the path through it, it basically follows sort of that exact hierarchy that you mentioned. As far as like upper level classes go, it starts with intro to data science, then an actual data science class, then a more like mathematical machine learning class, and then their senior year they do take an AI class. So it does sort of stack like that. But before all of that, their sophomore year, at the start of their sophomore years, we have students take what we call, our curriculum's undergoing some transition over the next year, but it's currently called computational science. In the future, it's going to be called AI tools. And basically what that class is a survey of all of those topics. It's high level. We provide a lot of the code for them, right? Because they don't have a ton of experience like building models from scratch or anything. But it's a high level. All right, so here's some data literacy stuff. Here's some machine learning models and basic like data science operations. And then here's sort of how it all ties together in the hierarchy. I think some level of that hierarchy is needed to go to advance to each level. For example, to do any sort of data science, you need to have data literacy, right? That's sort of the base piece. But whether that base piece is like in the Fuse program, I gave a lecture on failures in machine learning, and the basic punchline of that lecture is there's bias. And we don't talk about how to handle that bias because that sort of gets sort of mathematically in the weeds. But we mentioned that it's there and that it's something you should be on the lookout for. Right, and so even for our Fuse students who had an 8-week program, that's something we start talking about early on, before they start working with Sandy and Rex Academy to build those tech skills. And we talk about that in those intro classes at MSW, but we come back to them later on when we want to talk about again data literacy, like how do you remove bias from data? That's when you start talking about like oversampling, undersampling, data augmentations, those sorts of things to try and help fix the bias that you see. So I guess, yeah, at MSW, at least within the Fuse program, a bit, the hierarchy exists to an extent, but you can sort of, as soon as you have a base understanding of each piece, you can sort of plug and play.
So at Rex Academy, these courses are like kind of independent. So our data analytics course is data analytics. Like we start off with an Excel, because these are meant for middle school and high school students. They start off with Excel, they learn some basics of Excel, and they gather data sets. They figure ways how to gather data sets that are free out there and mostly gather data sets and analyze the data using Excel. And we also use few free softwares like Microsoft BI tools. So that's independent, and then like a programming language, either like Python for high school age, middle school age students, or for younger age we do it with Scratch, MIT. So that's an independent programming language class. And then AI, we do AI with Scratch for younger age. For high schoolers, we do AI with Python. So that kind of requires some language, some programming language, so that they can figure how to model or how to implement their model, AI model. So, but it could be like AI could still be taught independently, just on what is AI, ethics of AI, and also like modeling a machine. Maybe they won't be able to implement the model if they don't know the coding language, but they can still learn quite a bit about AI if they're not going to become a computer science person, but they might still get lots of benefit of learning AI. So all three are independent. But at Fuse program, we did make it a sequence, like we had first data analytics and then Python, and then AI with Python. Everything was tied together.
Great, thank you. So I let Gabe and Sandhya answer that question about like the hierarchy, but Ben and Michelle, how have either AI education or data literacy been blended or layered on complement to the other STEM programming or the other talent development programming that you've done at UW Milwaukee and Northwestern Mutual? You can speak to the curriculum kind of question that Gabe and Sandhya have, or how are you managing the blend of AI and data literacy into the overall kind of STEM landscape?
That's quite the complicated question. So for us, because of the way our program is set up, we're a project-based hands-on learning program. It's very open to students to take what they want, when they want, how they want. We offer about 250 classes each summer, and they are varied of classes in STEAM, so science, technology, engineering, arts, and math. As far as the AI questions involved with it, we do put a special emphasis on a lot of mathematical classes going as young as K-5. Most of those classes have a lot of probability and statistical knowledge base in it. At a very base level, most of our teachers are local teachers here from the greater Milwaukee area, with the majority of them being MPS teachers that are already doing some of that in their classrooms on a day-to-day basis. We also infuse a lot of different types of computer science classes in our programming for each summer. We offer coding classes. We offer, like I mentioned before, Lego robotics courses. We offer classes that have to do with computer programming, with game development, and web design. So it gives them opportunities to kind of learn some of those ins and outs and background knowledge in AI and also in computer sciences. And we also offer them opportunities to do entrepreneurship types of courses too. So it's really about the level of experience and understanding of the students. By the time they get to the high school age with us and we offer them our certificate program, at that point they've had lots of opportunities to take different courses in mathematical skills and computer skills, all the way up to taking some Python programming and things like that. And as far as of how else we can do it, we're always looking for more partnerships. We're always looking for more opportunities. This year, we're actually working with another organization on campus that is looking to partner with us to offer even more possibilities and opportunities for students as well. So,
I mean, I'm not going to lie. I feel like I'm still figuring this out a bit. But if I had to sum up what we're doing, how we're bringing things together, where I'm focusing most of my energy, and if I look strategically at our programs, it's really focused on the how we communicate it, the breaking down of silos. You know, we're looking at things like, how do we explain data science and AI projects to business partners? How do we clearly articulate the business value? And if we can help them to understand the business value, then we can bring them along for the ride to shore them up on some of the more technical pieces if they're understanding the context. So I think that's where my focus is on that communication piece and making sure that everybody understands what we're doing. Because if we're doing all this crazy technical stuff but nobody knows what's going on, you know, the black box model is the term that terrified me most when I was taking a data science course. And I'm like, but what's going on in there? How is it doing that? We need to understand how it's doing that and what it's doing. So that's the part that I think is really important.
All right, we have about 15 minutes left, so I'd like to open up to the audience if you have questions.
Thank you. Yeah, thanks. Great talk. Curious about the kind of the tail end of the classes. Once they've kind of built up these base skill sets, how are students able to connect jobs that they might be interested in or specialties that they're interested in, like computer vision, to those jobs?
Sure. So I'll comment for the bit I can about MSc. I'm only in my second year there, and I haven't taught all of the upper level courses. So as far as like the career development aspect of sort of the data science, AI, ML piece, the class that I've been most involved with that sort of builds into that is what we call data science practicum. It's the pitch for it is basically at the end of their junior year, we partner students up with industry partners who give us real world data sets and real world problems that they're working on. In some cases, it's I'm thinking about the projects I mentored. One of them was like we partnered with a startup that already had a solution to this problem, but they were just interested if, give the data to our students and see if they come up with something different that they maybe hadn't thought of before. Or in other cases, it was a really well-established company that, has been around for a long time and has never had a data scientist work for them. And they've been collecting data for the last, 5 years. And they've just sort of been throwing it in an Excel file and no one's touched it. And so they just handed off this really messy thing and said, oh, let's see what you can find. And so the way that project worked is all of the juniors were presented with, say, the 8 different potential projects, and they sort of got a bid about which one they thought they liked best. And so you mentioned computer vision. Like, one of them was a computer vision task. So students who really wanted to work in computer vision or get experience with that, they'd say that was my first choice, and we generally tried to get students in sort of as top of a choice as they could. So that gave them sort of real hands-on experience, building, working with, because we had, for each industry partner we had, there was someone at the company who was sort of like their project sponsor. So it gave students like experience, having professional communication with someone in industry, and working on a real sort of real world data, real world problem. And sort of a direct result of that, at the very end, it's a 10-week course. They present their their results of their project, and throughout the course, they're sort of writing up like a research paper equivalent of what they were doing. And that, gives them experience working on a project, they're hopefully interested in, because we tried to make teams with it. We had to fill out each team, but we tried to get, again, students sort of their top choice if possible. And if that went really well, which it often did for the most part, that project has led to students getting positions with the company that they were partnered with. Or I can think of at least a couple of internships, and I think the year before me led to one full-time position with those companies too.
Can I ask a follow-up question?
Sure.
The report that they have to do, is it like written like a research report, double spaced, or do they get to try to make it look like an actual business document?
So we have them write it like a research paper, because we're all academics who are teaching these classes. And during our PhDs, we've been all written like journal papers. And so it's written as, abstract, introduction, methods, results, conclusions, right? We have them write it in sections like that. That's sort of like their weekly deliverables to us. And we give them, I looked at my role as like, what my PhD advisor gave to me when I was writing papers as a graduate student. That's sort of how we formulated that paper. Yeah.
If you ever want to tinker with a business report option, let's talk.
Sure. Yeah. Yeah. Sounds good.
Other questions from the audience? Joe, the godfather of computer science, as he was introduced earlier this morning.
Good Lord. I'm going to come at this from a little different point of view. So being the godfather or the grandfather or whatever, I've been teaching computer science since the 70s. And we used to actually, engage kids with AI way before, all the data science stuff and all the machine learning stuff. So there's other areas of AI that you can explore, like using Prolog and using deep logic models and stuff like that don't involve massive amounts of data. So I guess my question in trying to formulate some kind of a question is how does the exploration of data science in this new field of data science, how does it inform the other areas of AI that, like the non-machine learning areas of AI? If that makes any sense. And Sandy, you were kind of getting at this a little bit, I think.
Yeah, if Sandy has a good answer, I'm going to punt to Sandy, because I don't know that I have a great answer for that. I'll think about it, and I'll punt to Sandy.
I was gonna copy some stuff from you. So I think you're referring to when I said like we teach AI with Scratch. So for the elementary school kids, you will be blown away when you ask them the question, what is AI? They do come up with the right answer, most of them. And so one thing that works, as we all know, like diversity and inclusiveness is extremely important. So all of our curriculum extremely focuses on that. And one thing that works extremely well with girls is we use social media, and with AI, like on how to identify social media, the themes on social media, the intent of the conversation or the intent of the comments. So that helps. Like they don't even realize that they're learning AI. It's more fun games. Like as you have said, like it's more logical thinking and figuring out, but it's more games they're playing and projects they're building, but it is AI.
You know, I mean, we used to have well, actually a program that we have the kids do some. Yeah, that's true. You know, in days gone past, we used to actually have the kids, you know, program or get involved with like an animal guessing game, which is basically a big binary tree. Or we used to do, and what's there's a famous list-based thing out of MIT where you talk and the computer responds back, and I can't remember the name of it now. It has a woman's name on it. I want to say like Esther or something like that. And we used to have the kids actually mess around with that and learn about that kind of stuff. And that didn't have really, in terms of, you know, when I think of data science, I'm thinking of, you know, analyzing massive amounts of data like we've got all over the place now. But we didn't have that then. But yet we were dealing with AI in many real ways. I mean, way back when the whole idea was started back in MIT. So I guess what I'm saying is that the data science piece of it, maybe it can inform these areas better, and we could have taught it better in the 70s and 80s and things like that. So I don't know.
So I can tell you a personal example from my home. I have a 6-year-old and a 4-year-old, and the technology that we have in our smart home is benefiting this conversation with my own kids. So with my Alexa device, with my Spotify app, I'm able to help my kids understand that these devices are learning from us, that the recommendation engine behind them, the Spotify knows what song we want to hear next because it's learning about what our choices have been in the past, right? And so what Liz would have said if Liz was here, though she's homesick and she's probably listening in, and so I have to do her justice by mentioning it, is I encourage all of you listening to Google the AI for K-12 Coalition, and it's a National Science Foundation funded work, and they break down 5 big ideas of AI that to explain that machines can perceive. So whether that's via data or some other device, they can perceive the world. They can represent the world and return a representation back to the user. They can learn in that data exchange. They can learn from those processes. Then they can have the artificial interaction with that user. And then at the end, that leads to an impact in society. Positive, negative, indifferent, right? And so those are the 5 big ideas of AI that the AI for K-12 Coalition recommends. And you can have those conversations with, like I said, my 4 and 6-year-old, and they're figuring out that all these devices, all these smart devices we have around us in our pockets are having interactions with the users behind them. Sandhya.
Yeah, I have a question for you guys. I mean, that's your question. I'm copying your question. So let's say, like, in 5 years, Wisconsin is a leader in manufacturing, agriculture, and healthcare. If, let's say, if we would like to be the leader in AI, the state that's the leader in the AI, what do you think we all should do?
Okay, I'm really going to pick on Gabe. Maybe we can tell somebody beyond people in the Lower East Side of Milwaukee that we have a supercomputer here and that Marquette has one too. I mean, go to the MSOE website and the summer program you talked about. Other than that, it's all from 2019. You know, some of us work hard at trying to publicize what Milwaukee's doing. We're in competition. I saw this one professor from Waterloo in Canada and talking about how we're the world's leader. And I thought, one professor all the time. Turns out all the little BlackBerry money went into Waterloo, 21 professors have been working for 15 years on making them an AI center. So it's just like we could have, a lot of cities go out there, name it and claim it. So, hey, we're an AI center. We could have done that 5 years ago because we had a building and we have a supercomputer and Marquette has a supercomputer. We could say we're an AI center and we'd be far ahead of most people. Dr. Dirk's boss bought a supercomputer without a building for Florida State University. They are hiring 100 professors in all fields that know how to do AI on a supercomputer. I mean, the comment I have to sum up is, what does Rosie do all day?
I can actually answer that. So, yeah, the first time students in their coursework get a chance to use Rosie is in their sophomore year in that what's currently called computational science in the future will be called AI tools class. And in that class, it's, again, largely we give them a sort of, already sort of cleaned up, already sort of like, nicely formatted data set. And then we say, okay, build a logistic regression model, which, doesn't really, you don't really need a supercomputer for that, but you can use it. And then towards the end of that class, we're building, computer vision neural networks, which do need the supercomputer. And, in that class, we talk about, well, okay, so, if you allocate 2 GPUs versus 4 GPUs for this job, do you actually see an increase in efficiency? And, we talk about where sort of the upper bounds of, using that parallelization that you can get with a supercomputer, how that the speed up that you see is really dependent on the task that you're given. That's something that we talk about a lot. And then in upper level class, like I said, that data science practicum class that I taught, where they are given that industry partnership. Often, I mean, it really depends on the partnership. Like the computer vision project, they ran all their stuff through Rosie because they sort of had to. Those computer vision models are really big models with really large data sets, and just not feasible to run on sort of the laptops that we give students. So it is used throughout the coursework. And then professors also, like my role at MSOE and all my colleagues' roles, with the exception of like a handful, we're mostly there for teaching. We're not like an R1 school. That doesn't mean that professors don't do research. There are a couple that do research, and I can think of one of my colleagues who was hired at the same time I was, that is, as sort of in the year and a half we've been there, gotten famous for, students are trying to run their homework on Rosie, and Dr. Powers is using up all of the GPUs, so it can't be done. So there are professors that do use it, but our role as a sort of a teaching-focused school, it's not utilized for, promotional research as much as it probably could be. Yeah.
If we say R1 universities, I mean, MSOE is close enough, right? I mean, we say we have 5, including MSOE. But all that you said, if I wanted to say something on social media that Milwaukee's an AI center, I would go to Direct Supply's website where they say we use our big secret a supercomputer across the street. They actually have in parentheses like this cough thing about it. So even they're quiet about it.
Yeah.
And so I appreciate what you do and the training, but it's just like we have a supercomputer from say somewhere in 2022 rather than when the building was dedicated.
Sure.
Yep.
And I know we actually had a meeting at one of our department meetings that sort of the marketing side of MSOE is trying to promote our new, because the CS major is pretty new. They've had SC for a long time. The CS is new. They're trying to promote that and promote sort of like the facilities and the, so maybe we'll see more of that coming up. But that is sort of outside of my purview.
So
Yes. Yeah.
Right. We have just a minute to go, but I want to end with this question, and we don't all have to answer, but how are you addressing equity in the profession, and whether through your programs or your outreach, or we could get into bias and all that, but that's too weedy for a last question. So let's just, can I hear how you've addressed equity or what you plan to do in the future to diversify the AI space?
First and foremost is that we try to give as many students access as possible. We do so by partnering with several different George. We have a couple different partners that help us with funding to help give scholarships to students so they can come to our programs. Giving them access, giving them opportunity is the first and foremost thing you can do to create equity. I think a lot of our students, probably 80% of our students, are Milwaukee Public School students, and they don't have the necessities at their schools most of the time to be able to offer some of the things that we're talking about. So like what I was saying, the first teacher who taught our introduction class, she came from Franklin High School, and they had a data science class. But if you went to most high schools here in the city, most of them wouldn't even know where to begin and not have the necessities. Right now they're struggling on a day-to-day basis just to have classrooms and have teachers in their spaces. So from our perspective, we're an enrichment program, so we are doing our best to partner with schools, with non-for-profit organizations, and with industry leaders to do what we can to give access to students.
Data literacy is for everyone. That is the message I am trying to get out there. And I think in the workplace, I've been doing things like a roadshow presentation.
We include different perspectives when we are writing curriculum. So the curriculum itself, the people who are writing, they're conscious and they are people from diverse groups, diverse experiences. And like Ben has mentioned, our mission is to address inclusiveness and equity in computer science that includes AI.
And so I can talk sort of in both my roles. We actually just had a meeting about this not that long ago at MSOE. I certainly see in my computer science classes that diversity is something that needs to be improved. We are both, I'd say, culturally and especially in terms of gender representation. We have being an engineering school, the school as a whole skews mostly male, and especially within the computer science program, we skew very heavily male. I know that's something that we're trying to address, and we're trying to, sort of recruit outside of those traditional roles. But I know that's something that MSOE has started seeing as an uphill battle. Within the FUSE program, that program is really targeted at trying to help get, again, people who may not see themselves in a tech career, more underrepresented people, to get sort of their foot in the door in tech. And so both of that is sort of where we advertise to that program to, removing barriers to be in the program. Right, that program is funded by the Milwaukee Tech Hub and all of Milwaukee Tech Hub's partners, so it has no cost. I know we had one student too who said they didn't have like regular access to a laptop, and I think we arranged with the Tech Hub arranged with someone to help get a laptop for them for the summer. And lastly, I mentioned in my very first answer to sort of what the FUSE program was, we created sort of these panel discussions with people in industry. We tried to highlight sort of voices of people who maybe didn't have a traditional path to their careers in tech and how they got to the places that they are. And so we're trying to like show like, hey, yes, you can be successful. Here are people who look like you, maybe have the same background as you, who are currently successful in sort of the Milwaukee tech world.